Today's lesson is on truth tables. So far we've only classified statements with English words and mathematical symbols, whether or not the statements were true or false. But in this lesson, we're going to investigate the truth of the statement in an organized way called truth tables. By assigning a truth value to each statement. So if we have two statements, so let's say I have P is I eat green eggs and Q is I eat ham. Okay, so we have two statements. Because the situation has two statements, there's four possible cases. Let me show you those four. Either P is true and Q is true. P is true and Q is false. P is false and Q is true, or they're both false. These are the four possible cases if one is true or the other one is true or false or whatever. So there's four different cases we need to talk about. Now we have 5 compound statements where we're using and, or, not, and if-thens. And we want to make sure we know what the truth value is. Now, the cool thing about truth tables is we're going to learn all of the different cases, whether it's true or false, for if P is true, if Q is false, and we're going to learn the whole thing, okay? So if we're trying to negate P, well, when we're talking about P, we're only talking about this column right here. We're not talking about the Q at all. So what is the negation of P? Well, if P is true, so I eat green eggs is true, not P would mean false. Okay, so if P is true, then not P is false. Well, what if P is false here? Well, then the negation would be the opposite, which is true. So the way we find the negation truth values would be, it's just the opposite of whatever the column that you're working on is. That's probably the easiest one of them all. The next one is the conjunction. Remember the conjunction? That's and. Okay, so when I'm talking about and, that's kind of like if I have the Venn diagram, it's got to be both in the first circle and the second circle. So I'm talking about that one spot in the middle that's overlapping, right? It's the only thing that's going to be overlapping. So if it's a conjunction, we have true and true. Well, if it's true in the first circle and it's true in the second circle, then and is also going to be true. Now, if either one of these is false, P and Q must then be false. Even if it's true for the P, if it's not also true for the Q, then the whole thing is false. So because each one of the next ones have a false in it, the rest of them are going to be false. So the way we remember that conjunction is just basically it's true when both are true and then everything else is false. Because if one of the two is false, the and can't be true, it has to be false. For the disjunction, that's an or. Now for the disjunction, remember, that would be like if it's in the first circle or if it's in the second circle, so it's like both, right? So as long as it's true for one of the two, ors is also going to be true. So if we have true, true, the disjunction will also then be true. We have true, false, well, at least one of them's true, the whole thing's true, because or could be one or the other. False, true, well, one of them's true, so the whole thing's true. What about false, false? If they're both false, then P or Q is also then false. So the short way of remembering that is disjunctions are always false when both are false. Next, we have the conditional. That's the if-then. So we have P, which is the antecedent, and Q, which is the consequent. So if the P antecedent is true, then Q is also true. That's the first one. If true, then that's going to also be true. Okay? What about if true, then false? If the antecedent is true, so let's say I do eat green eggs, then I eat ham, but I don't actually eat the ham, then I've actually falsified that statement, okay? So if true, then false, that's not okay. Well, what about if false, then true? If the first part is false, if the antecedent is false, it really doesn't matter what happens after that. If the first part is false, then it doesn't matter what your statement was, because it's going to be okay, because the first part is false, then the next part doesn't matter. So if the first part is false, then the answer is always going to be true for conditional. So the shortcut here is if it's only false when P, the antecedent, is true, but then the consequent Q is false. That's the only time it's false. Because if the antecedent is false, then your statement is still valid. So biconditional. Biconditional. So that's if true, then true. And then also if true, then true backwards, right? Because we're basically, for biconditional, we're going if P, then Q, and if Q, then P. So if true, then true, cool. If true, then true, also cool. The next one, true, false. If true, then false, that's not okay. I don't even have to go backwards, because if one part's false, then the whole thing's false. How about if false, then true? So if false, then true, that's okay, but what if I turned it around and did if Q, then P? So if Q, then P would be if true, then false. Nope, that's not okay. How about the last one? If false, then false. Nope, that's okay. Because if the first part's false, it doesn't really matter what the second part is. How about if I turn it around? If false, then false. That's okay too. So this one's really weird. If false, then false is actually an okay for biconditional. Okay, so that's a true, because it can go either way. So the shortcut here is true only when P and Q have the same truth value. So these instructions here at the bottom are most important for all of today, okay? All of the truth values, the truth tables we're trying to do. These shortcuts are going to tell you how to do this. Whether or not you have the actual P or Q statements, you can do a truth value for a symbolic notation without actually knowing what the two statements are. So I could have done this whole thing without actually knowing P is I eat green eggs and Q is I eat ham. I can still do the whole truth table without that. Let's try this again. Here's another example. Complete the following truth table for not P, that's an or, that's a disjunction, not Q. So I have P and I have Q, and I have all four combinations of true and false. So I've already kind of labeled some columns here. Eventually you're going to start labeling your own columns, but I have to first find out what not P is, then I have to find out what not Q is, and then I'm going to take those two columns and do the disjunction between them. So not P is I'm taking the P column and doing the negation of that. So that's going to be false, false, true, true. Next I'm going to be not Q. So in not Q, I'm looking at the Q column only, and I've got the opposite of true, which is false, the opposite of false, which is true, the opposite of true, which is false, and the opposite of false, which is true. Okay, now I have to do the disjunction. So when I'm doing the disjunction of not P or not Q, I'm looking at the two columns not P and not Q. I don't have to worry about the blue or the yellow anymore. I'm just looking at the green, okay? So when I'm doing the green, or, let's see, for disjunction, the rule for or was false only when both are false, okay? So if they're both false, then the whole thing's false. So false, false is going to mean false. Anything with any true is going to end up being true, because that's what the or statement says. Is if both of them are false, then the whole thing is going to be false. So there's my truth table. I can now compare the original P and Q. So if the original P, whatever it was true, and the original P, Q was true, then I can look all the way to the end result and tell you that if not P and or not Q, the answer will be false. Okay, so this organizes all of our truth into one table. The next one I have P and Q in parentheses, so I have to do that first. or not Q. So the first thing I probably want to do is the parentheses. So I'm going to do P and Q, and then later I'll come back and do the or. Okay, so this is and, which is a conjunction. So I have P and Q, and I'm trying to find out what the and is. And or conjunction means it's true only when both are true. So true, true gets me true. True, false. If anything's false for and, the whole thing's false. So if anything is false, the whole thing's false. Both are false, I don't care, the whole thing's false. Okay? The only time and is true is if they're both true. Okay, so I've got that first part done. Now I need to evaluate the not Q. So at this time, I'm only looking in the Q column. Not Q just negates whatever the truth value is. So if Q is true, not Q is false. If Q is false, then true, true, then false, just the opposite, all the way down. Okay, so I've got not true. Now I have to do the or the disjunction. Okay, so I'm going to take my green column, P and Q, and I'm going to do the disjunction between the blue column, not Q, and that's going to get me my final answer. Okay, so I'm doing the disjunction. Now the disjunction is false only when both are false. So I'm looking here, true, false. Well, one of them's true, so that means the whole thing's true. False, true. Well, one of them is true, so the whole thing's true. False, false. Okay, for disjunction, when they're both false, the answer is false. And false, true, because one of them is true, the whole thing is true. And that is going to complete my truth table for P and Q or not Q.